All right, this lesson is on congruent figures, recognizing congruent figures and their corresponding parts. What we know is that two figures will be congruent if they have the same size and the same shape. So, same size, same shape. This basically means that all corresponding, now I'm going to use this word corresponding, this unit. You know in the last unit, we used the word corresponding as well, right? So our definition of corresponding in the last unit were angles that were in the same position, correct? So here, when we're using the term corresponding, we mean the same thing. Angles in the same position, side lengths in the same position. So when we're looking at two figures being congruent, we're going to say that their corresponding parts would be the angles that would match up in the same position. So corresponding angles are congruent, and corresponding sides need to be congruent. So corresponding angles congruent, corresponding sides congruent, in order for two figures to be considered congruent. And here, congruent figures have the same congruent matching parts. If we look at these two figures, see how A is red? So its corresponding part is what? E. Notice this statement right here. This is called a congruence statement. And a congruent statement will have the corresponding parts aligning. This is what I mean by that. See how angle A is listed first. What angle is listed first here? E. Therefore, A and E are corresponding parts. If I said line segment BC, what would that correspond to over here? FG. So you can get the alignment and the corresponding parts straight from what we call a congruent statement. So you can obviously also get it from the diagrams. AB would correspond to EF, GH corresponds to CD, so on and so forth. But this congruent statement is also very helpful. So let's look at this next one. We've got ABC congruent to XYZ. Please insert a little triangle here. Triangle ABC is congruent to triangle XYZ. And if we want, don't look at that diagram. Let's label the corresponding angles. Angle A would be congruent to what angle? Angle X. Angle B is congruent to angle Y. Angle C is congruent to angle Z. And notice, you don't even have to look at the diagram to know that. Side AB is congruent to side XY. Side BC is congruent to side BC, or the last two here, YZ. And then if I said side AC, what would that be congruent to? AC is XZ. Very good. So we've got all the corresponding parts. Now for the picture, I could label A as congruent to X with one arc. B is congruent to Y with two arcs. And then C, I'm going to do an arc and a slash, is congruent to Z. And then I've got AB, one slash, congruent to XY, one slash. BC, congruent to YZ. And then AC, three slashes, congruent to XZ. So with the diagram, we can mark the corresponding parts congruent. And then we can also just use the congruence statement to gather what corresponding parts are for the angles and the sides. All right, let's go to the next slide. We've got the wings of an SR-71 Blackbird aircraft, suggesting congruent triangles. What's the measure of D? So if we know that these two triangles are congruent, then we know that corresponding parts are congruent. So B is congruent to E. What would C be congruent to? F. And so I could put 75 degrees in here, and then can we solve for angle D? Sure. The measure of angle D will be what? Now, because these all add up to 180, it is also actually 75. Very good. Questions? Okay, here we've got two triangles. The question is, are these triangles congruent? In order to say that they are, we have to be able to establish all corresponding angles congruent and all corresponding sides congruent. So let's look at the sides. We've got AB is congruent to DE. Now, I don't have the markings for the other ones, but I do know that 4 is congruent to 4. So I'm going to put 2 slashes there. I know 6 is congruent to 6. So I'm going to put 3 there. I can see that I've got all 3 sides congruent to all 3 sides. Now let's look at the angles. A is congruent to E. B, 2 arcs, is congruent to D, 2 arcs. But I don't have the third angles. Can I get the third angles? Why? What's the reasoning? Vertical. So by vertical angles being congruent, now I've got all 3 angles congruent to all 3 angles. Are the triangles congruent? Yes. All corresponding sides and angles are congruent, also known as corresponding parts are congruent. I just want to be a little more specific at this moment. Is triangle ABD congruent to triangle CBD? Now the question is, are they congruent based on what you see? And all we have are these 2 slashes, and that's it. So talk with your group, and then we'll go over it. So I like that. We don't have anything else other than I did hear over here, DB is congruent to DB. That is true by the reflexive property. So you can get 2 sides of one congruent to 2 sides of the other, but can we get third sides? No. And be careful if your brain went to, wait, they add up to 180. Sides do not add up to 180. Angles do. So be careful. So we can't get the third sides, and we know nothing about the angles. So this is no, not enough information. Oops. Ugh. Not enough info. All right. Remember, solve for x. What would the measure of x be? Okay, 32 degrees is correct because the angles of any triangle add up to be 180, right? Let's go to the next page. What do we know about, and I'm going to ask you more specifically, angle A and angle Z. What do we know about angle A and angle Z? They're both going to be 32 degrees, right? Now the question is this true if we make it a general statement? If I have 2 angles of one triangle congruent to 2 angles of the other, notice how that's more general, then third angles will be congruent. Would that always be a true statement?
Yes.
Why? Because they always add up to 180. That's exactly right. So this is a theorem. It's called the third angles theorem. Now this third angles theorem is the title. And if you're like me, you're going to forget the title. But logically, you can just remember this and use this. If 2 angles of one triangle are congruent to 2 angles of the other, then third angles are congruent. Now, granted, that's a lot to write out, but you can always write that out. Before we start using the third angles theorem, I think we should prove the third angles theorem. So let's go down here to the proof for the third angles theorem. Here we are given two angles of one triangle congruent to two angles of the other. Our goal is to prove that the third angles are congruent. So number one is given. Then what allows us for line 2 to go from saying that the angles are congruent, therefore the measures are equal. That is definition of congruence. Now for 3, I'm saying that all of the angles of the one triangle add up to 180. All the angles of the other add up to 180. What allows me to say that? You know, I like what you said. All angles of a triangle add up to 180. That's perfectly fine. The title is the triangle angle sum theorem. But hey, if you're like me, you're not going to remember the titles. So just write it out. All angles of a triangle add up to 180. That's perfectly fine. 4. Now, before you put your reasoning for 4, I want you to think of this. There's 2 definitions I want you to know. Transitive is when 2 things equal the same thing. Substitution is where you're replacing with an equivalent value. So before you put your reasoning for 4, check it with your group and see what you guys think. So there's definitely a feel to this one. This is equal to 180. That is equal to 180. So this is equal to that is transitive. Should you feel bad if you put substitution? No. I would count it right. State of Ohio might not. Okay. Now, for 5, what is happening? Yeah, you are replacing this with an equivalent value. Therefore, this is substitution. Now, what'd you do to 5 to get 6? You did. You subtracted off all the common angles. So this is subtraction. Property of equality. And then what allows us to go from 6 to 7? Measures equal, angles congruent. Definition of congruence. Excellent. Excellent job. Okay, go into this next one. This is sort of starting the classic kind of proofs that you'll see in this unit. You've got 2 triangles. You've got a diagram. This one has a lot that's given. And notice how the given is already marked on this diagram. Perfect. So number 1, this is part of the given right here. But what allows us to say that side LN is congruent to side LN? That is reflexive. We're going to use that a lot. What allows us to say that M and O are congruent? What's line 3? Notice it's also part of the given. See that?
Would the 4th one also be given? Or would it...
No. The 4th one is interesting. Angle MNL is congruent to angle ONL. What makes those 2 angles congruent? What were you going to say?
Reflexive.
No. So reflexive will have it kind of basically on top of one another. See how LN is shared between the 2? The same thing will happen with angles. These 2 guys are beside each other. They're sharing one ray, but that's not going to be reflexive. We do have, this is a clue, 2 angles of one triangle congruent to 2 angles of the other. Third angles theorem. It's obscure. It will pop up on occasion, but it is very useful. Third angles theorem. Now that we've established all corresponding angles congruent, all corresponding sides congruent, we can state that the 2 triangles are congruent since all corresponding parts, bad writing, are congruent. All corresponding parts are congruent. Go to the next proof, work on that with your group, and then we'll go over it. All right, let's go over this. Number one, what's the answer? Reason? Given. All of those givens are marked. That's another thing that through this unit, you want to make sure you mark that diagram as you go, because eventually we're going to learn some shortcuts to prove two triangles congruent, and the only way to tell what shortcut works is by looking at the diagram that's marked. Okay, so the given, it's already marked. 2, what allows us to say that these two angles here are congruent? Vertical. Vertical. And then 3, AEB, these two angles, yes. 2 angles of one triangle congruent to 2 angles of the other, third angles congruent. Third angles theorem. Now the 2 triangles are congruent because all corresponding parts are congruent. Well done. Okay.